Okay, Math 3, Unit 1, Section 3. We are continuing writing equations, but now we're going to do them with the translations that we learned in Section 2. So if you remember, when we're talking about linear equations, if we were looking at the horizontal and vertical translations, I still have a slope, but I wrote it in this modified slope-intercept form, where it was like -0 plus 0. That was if my origin was where? My origin, 0, 0. My origin's always at 0, 0. That is if my linear function passed through the origin at 0, 0. Now we're going to do it with a shift, actually two shifts. So I'm going to pick one of these starting points, and you'll find out that you can use either point that is given, but I'm going to use the one on the left, and I'm highlighting it so I can remember which one I used. So I still have m and then x minus something plus something at the end. Now, I'm not going to write the plus something at the end, because if it's negative, then I'm going to end up having to write minus that. So after x, let's figure out this point in order to plug it in for my horizontal and vertical shifts. So this point is -5 what? -2. So if that's -5, -2, how am I going to write this inside the parentheses? Oh, +5, so +5. So remember, we want to know if I plug in that -5 here, I should get 0. Or in other words, these are opposite. And then I'm going down 2, so that is -2. Now, in order to write the equation, I need to have all of my constants filled in. So I have a constant slope here, which means I need to find out what the slope is. We have two options. We can use the formula for slope, which we're going to actually write out. Does anyone remember the formula for slope? Very good. y2 minus y1 over x2 minus x1. Now, you could actually count the slope here because it's graphed. If it is not graphed for you and it only gives you the points, you would want to use the slope formula. And by doing that, I would just use this point as well as my second point, which is over 1 up 2. Alright, so if I use this one as my y2, I'm going to do -2 minus y1 minus 2 over -5 minus 1. Which gives me -4 over -6 that reduces to 2/3. Good. So my slope is 2/3. I could have counted that. I could have gone up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, and then reduced to 2/3. I'm going to plug that in to my equation that I already have. And that would be my final answer. Now, if you chose to use the other point as your starting point, your equation would look different. but they simplify to the same slope-intercept form. So you could also simplify this, and if I were to distribute the 2/3, I would get y equals 2/3 x. 2/3 times 5, I would multiply it as 5 over 1. So I would get 10 over 3. And you would want to do 10 over 3 minus 2. So how can I write 2 as an equivalent fraction with a denominator of 3? The denominator's 3. I want this to equal 2. 6. Good. 6 divided by 3 is 2. So then I could condense those and get y equals 2/3 x plus 4/3, because 10 minus 6 is 4. Okay, so this is what I'm looking for, this first one. But realize you're going to have two separate answers depending on which point you use. I will accept either of those answers. Both will be correct solutions. If it asks you, in any case in the future, to write in slope-intercept form, you just want to make sure you're distributing and then simplifying. Questions about the linear function on number 1? The 10/3 is 2/3 when I distributed to the 5. 2/3 times 5 is 10/3 because I do 2 times 5 and 3 times 1. And then the 6/3, I wanted to make sure these were two that I could combine together. So I got a common denominator by changing this 2 to 6 over 3 by multiplying the numerator and denominator by 3. Good question. Okay, the next one we're not going to simplify to slope-intercept form. We're just going to leave it in this modified point-slope form. Okay, so going down to the next linear problem, I still want y equals m x plus or minus something inside the parentheses and then plus something at the end. So we're going to pick one of these points. I'm just going to pick the first one we come across from left to right. So this is -1, 4. So if that's -1, +4, what am I going to put inside the parentheses? X plus 1. Very good, because I have to do the opposite. And then with the 4, plus 4, because it's got to be the same. And then all I have to do is find the slope. In this case, I'm going to do rise over run. You can still use the slope formula, but since it's already graphed for us, we're going to make our life easy and just count how far apart these are. So go ahead and count down and to the right. Okay, what we get? Down how many? Down 10 and over 4. Very good. Can I reduce that? Yes. If I divide each of those by 2, I get -5 over 2. I'm going to plug my slope in to my equation. -5 over 2, x plus 1 plus 4. Again, you could change this into slope-intercept form. We're going to leave it like that. And you'll leave it like that on your homework as well. Questions? Okay, moving on to quadratic. Same idea, except for we don't have a slope, so we can't count up 1 over however many. And we can't, and we'll have a exponent of 2 because it's quadratic. So let's talk about our horizontal shift first. So we're going to write our equation out. Remember to use an a value. The only ones with slopes are the straight lines, and this is quadratic, so it's a curve. And then I'm always looking at my vertex when I'm looking at my horizontal and vertical translations, because my form, my vertex form is x minus h squared plus k. So y equals a times x minus h squared plus k. So I'm finding that h and k from my vertex. What is my vertex? For what? Oh, yeah, -3. Remember, that is your h, this is your k. So if it's a +4, what do I want to write inside the parentheses? -4, and then a -3 is -3. Okay. Now remember, my a value, I cannot say to the next point it's up 2 over 2, because my a value is not equal to 1 in this equation. If it was directly to the next point to the right, you could figure out the a value on the graph, but it's between lattice points here, so I can't figure out exactly whether it's going a half or a third or 2/3. So I'm going to find a second point on my graph, which is this one right here. That point is 6, -1 over 6 down 1. What am I going to do at that point? Plug it in. Plug it in for x and y. So I have an h and a k for my vertex, and then I'm going to plug in x and y using the other point. Oop. Which means I actually need to plug it in and not write my y. So you're going to plug in y, which is -1, equals, we don't know the a value yet, so I'm going to leave that there. My x is 6 -4 squared -3. And now we can start simplifying. So 6 minus 4 is 2. And I know what 2 squared is, so we're just going to skip ahead to do 2 squared times a. 2 squared is 4. So I get 4 times a minus 3. Again, I did 2 squared, which is 4 times a. How can I start solving for a? Good. Add 3 to each side. -1 plus 3 is 2. Good. Divide by 4. So a equals 2/4, which reduces to 1/2. So now I'm going to write my equation out. Remember, we're going to go back to using x and y so it can represent every point on the graph. So we have y equals my a value of 1/2. And then the rest of what we plugged in for our vertex should be the same. X minus 4 squared minus 3. Okay, go ahead and try the next quadratic one on your own. Okay, what's my vertex in this function? Good, -1, 3. Which means when I write out vertex form, am I going to have x plus 1 or x minus 1? X plus 1, very good. So it's going to be the opposite. Because I want to be able to plug that vertex in, or that x value of my vertex to get 0 here. And then plus 3, because I have a positive k value. My other point, what other point did it give me? Awesome, -4, -1. So I'm going to plug in that point for my x and y. So I have -1, a times -4 plus 1 squared plus 3. -4 plus 1 is -3. What is -3 squared? 9. So then I start to solve for a by subtracting 3 to the other side. -4 equals 9a, which means a is equal to -4 over 9. All I did was divide by 9 on each side. Okay, so when I write my equation out, I put that a value in, -4 over 9. I still have x plus 1 squared plus 3. Questions on writing an equation in quadratic form? Okay, the linear absolute value ones are a little bit easier because you can count the slope just like we did in our linear equations. So because it's a straight line, I'm going to use m for slope instead of an a value. But I'm still going to use this vertex. What vertex do I have for this problem? 4, 2. 4, 2. So if it's a positive 4 inside my absolute value, I'm going to write minus 4. And a positive y value of 2 means plus 2. Then all I have to do is find my slope. Remember, this is an absolute value problem. We're going to go up and to the right or up and to the left. But if my absolute value is opening up, what type of slope do I have? Positive. So even if I count between these points and it's down 3 over 1, it's not a slope of negative 3 unless your absolute value is opening down. Okay? And that's just because it's symmetrical. It's going to have the positive slope and the exact same negative slope within the same function. But it's opening up, so this is a positive 3. Again, that was my rise down 3 over 1. But it's positive, so it would be like looking at the right-hand side of going up 3 over 1. And that's it. We just have to plug it in and rewrite our equation. And we already have our translations and our slope plugged in, so we're good. And then showing a negative version, same thing. I start with my vertex because that'll show my translation. I'm going left 3 up 2. Good. Negative 3, 2 is what I heard. So inside my absolute value is x plus 3. Very good. And then at the end is plus 2 for my positive 2. What is my slope here? Down 3 over 2. And then I want to determine the positive or negative based off of whether this is opening up or down. And it's opening down, so that means this is a negative slope. So I plug my slope in to my equation, and that gives me my answer for writing my equation. Okay, next we have exponential. Remember, my translations are still like right next to my x value, and then whatever's happening to my function for the very last piece in my order of operations. So whatever happens last is addition and subtraction in order of operations, because if you have PEMDAS, addition and subtraction is last. So that plus or minus 2 at the very end is my change for my y value. I'll still have that in exponential, but in this case, my x value changes in my exponent. So the starting point I'm looking at is where this function is turning, which is right here. So for the parent graph, what's your parent point? Yeah, so the parent point for exponential is your parent graph's starting point, which is 0, 1. This starting point has moved, and we need to make sure we're moving from the parent point of 0, 1. So we can't just look at that point itself. We need to see how far it moved from 0, 1. This point is 3, -3. But those are not the numbers necessarily that we're going to plug in. We have to look where it changed from 0, 1. So we actually go to the right, how many? To the right 3. Is that addition or subtraction if I'm moving to the right? So I have to do the opposite, remember? Yeah, so that's subtraction. And then how far am I moving down? 4. I'm actually moving down 4. That's why I can't use the y value of my starting point for this function. I have to go from the parent point, which is one above the x-axis. Okay, so remember your x values are still opposite. So if I go to the right, that means I subtract. If I go to the left, that means I add. And now I need to find how fast this is increasing. And I do that based off of my next point. This point right here is over 6 up how many? 4. Awesome. Okay, so we're going to plug that in. We get 4 equals b to the 6 minus 3 minus 4. 6 minus 3 is 3. How do I start solving for b? Add 4 to both sides. Very good. And then I get b to the third power equals 8. What number raised to the third power gives you 8? 2. So my b value is equal to 2. So when I write my equation, I want to fill in my b value of 2. My translation shows me 3 to the right, so x minus 3, and down 4, so minus 4 at the end. Okay, we're going to try that again because that one was more complicated than the other ones, just because we have to look from our parent point, which is at 0, 1. If I'm going from this parent point, I'm going 2 left and up 3. 2 to the left means x what? Plus 2. And up 3 is plus 3 at the end. Okay, it's hard to see, but there is another point right here. That point is at -1, 6? Yeah, 6. So if we plug that in, we get 6 equals b to the -1 plus 2 plus 3. That's really nice because we'll get b to the first power, which is just b. So when I subtract 3 from each side, what do I get? Good. B is equal to 3. And I write my equation out. 3 to the x plus 2 plus 3. Questions on that one? We went through it kind of quickly just because my b value is 3. All I had to do is plug it in for b. So the most important thing to remember on exponential is to start at your parent point of 0, 1, and then do your translation. My starting point is going to be the one that's 1 away from my asymptote. Also, this value at the end will always be where your asymptote is at, because we're going to shift up from 0, 1, 2, 3, and those should match as well. This asymptote is at y equals 3. Okay, move on to the back side. Okay, it says find and simplify f of x plus g of x. Then sketch f of x plus g of x. So first of all, I'm going to add these together and then determine what type of function I have. So if I do f of x first, I'm going to write that out, which is 3 minus x squared minus x cubed. And then I'm adding my second function to that. So if I'm adding, then that doesn't change the sign of any of my values. And I'm just adding everything else. Order of operations. What should I do? Okay, can I simplify inside these parentheses? No, 5 minus x is already simplified. What comes after parentheses? Exponents. I don't need to simplify these x cubes because I can't. And then multiplication. Multiplication and division from left to right. So multiplication here would be my distributing. I know some of you think of this as parentheses. This is actually the multiplication step. So I'm going to write all of this out. F of x plus g of x. My equation hasn't changed until I get to my distributing, which is negative 5x. And what's negative x times negative x? Very good. Positive x squared. So I have some 0 pairs, which just means they add up to 0. They're opposites. Positive x and negative x squared add up to 0. Negative x cubed and positive x cubed also add up to 0. So that means with my function, all I have left is what? Negative 5x and 3. And I'm going to write it as negative 5x, and I have a positive 3. So I write plus 3. Why did I put the negative 5x first? Yeah, so I'm putting it in standard form. The x comes first. How can I tell what kind of equation this is now? Or function this is? mx plus b means it's linear. So you're just going to graph it using y equals mx plus b. My y-intercept is positive 3. My slope is down 5 over 1. Normally we want 3 lattice points, but my third lattice point is going to be off the graph, so I'm just going to, it's really close to being on the graph. If I go up 5 over 1, it's right there. What's my domain of this function? I know the question didn't ask you to do that, but just for practice. Awesome. What's the range? Good. Both of them are negative infinity to positive infinity because it goes left, right, up, and down forever. Okay, so we have two more. We're going to do the second one together. Then you're going to do the third one on your own, but we're going to set it up together so you'll see what that looks like. So for the second one, we're going to subtract f of x minus g of x. Now my g of x is just 4, so we're only going to subtract 4 from the end of this equation. I'm just going to subtract 4. What do I need to do to simplify this function? Seven minus 4. That's it. Okay, some people were overthinking this one and they want to multiply x minus 1 times x minus 1 and like multiply all this out. But remember, we're going to leave it in vertex form if it's a quadratic, point slope form if it's linear. Y-intercept form is okay if it already was in y-intercept form. Seven minus 4 is 3. What type of function is this? Quadratic. Very good. What is my vertex? 1, 3. Good. Okay, so I already know the 1 and the 3 from my vertex, so I'm going to plot that. But in order to get 2 more lattice points, I need to plug in a number. Remember, your axis of symmetry goes straight through the center. We want to pick an x value to the right or to the left of that. 2. Awesome. So if I plug in 2 for my x value, that gives me 2 minus 1, which is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 3 is 5. So the point over 2 up 5 is a lattice point. What would be the reflected point across my axis of symmetry? 0, 5. Perfect. Now, you'll notice that my a value was 2. So the point directly to the right went up 2. But if this is a fraction and it goes up by a half, you can't use that because we have to find lattice points, which means it has to be a whole number. Okay, so that can only work if your a value is a whole number. Because I want you to plot 3 lattice points. Alright. The next one, we're going to set it up together, and then you're going to graph it. What is this called? You know what kind of function it is when we put the g of x inside where the x normally is? A composite function. So composite means you're just composing them together, putting one inside the other. So we're going to take g of x and plug it in for x into the f of x equation. So we get 4 minus 2. We're going to open our parentheses where we see our x. insert the x plus 3. What goes after the parentheses? Squared, because our x was squared. And the parentheses represents where x is. Now, we need to rewrite this in order for us to graph it easier. If I want it in vertex form, because it is quadratic, because of that square, if I want it in vertex form, what number is going to be at the very end? The 4. Okay, this is a positive 4. My a value is what's being multiplied in front of my parentheses. So what number is being multiplied to the parentheses? Negative 2. Make sure you keep the sign with the 2. And this is a positive 4, so we're going to add 4 to the end. What's my vertex? Negative 3, 4. Bless you. All right. Go ahead and graph this one. Starting with the vertex and getting 2 more points. The vertex is the opposite number here and the same value here. So it's our translation. Okay, what number did you guys plug in? Negative 2. That's a good number because that's going to make this a positive 1 inside my parentheses. And if this is 1, then 1 squared is 1. So I'm doing negative 2 plus 4, which is 2. My axis of symmetry gives me another point where? Negative 4, 2. That's it. Good job. Okay, your homework is on the board.